Lesson 17.4, Task 1. Use special factoring patterns to solve quadratic equations. Factor the difference of squares. All right, so this is something you're going to see on a regular basis. So again, if you can commit this formula to memory, it's a big topic in all your math classes and especially on the ACT. So it says factor the difference of squares. Recall that the product of a sum and a difference in the form a plus b times a minus b generates the expression a squared minus b squared when expanded. For example, x plus 2 times x minus 2 can be found using the table shown. So remember when we were doing distributive property and we put x plus 2 and x minus 2. X times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. And then 2 times negative 2 is negative 4. So you can see that these two terms will cancel, and that comes because of the same binomial, different signs in the middle. So what is left is x squared minus 4. You can factor expressions that are difference of squares by using the factoring pattern shown. All right, so this should be in your notes. It is called a difference of squares, and it's just because of the name, it's a perfect square minus a perfect square. So minus is your difference. Difference of squares directly comes from what you have. A difference of two perfect squares. So anytime you have that, you're going to have a plus b times a minus b. Okay? So here's some examples. X squared minus 9. X squared is a perfect square, x times x, and then 9 is a perfect square because 3 times 3, or 3 squared, is 9. All right, so that means you could rewrite this as x plus 3 and x minus 3, and that is x squared minus 9, okay? 9x squared minus 1, 3x squared, this does have to be in parentheses because 3 squared and x squared produces 9x squared, and then 1 squared is just 1. So both of these, again, are perfect squares, and this is a difference of squares. So you can rewrite this as 3x plus 1 and 3x minus 1. And this is just a factored form of this expression. These are kind of easy to pick out, more so than the others, because these are 2 terms instead of 3 terms. So just a little note, if you see 2 terms, meaning it's a binomial, check to see if it's a difference of squares. All right, to completely factor an expression, factor out its greatest common factor first. You always want to factor out a greatest common factor. This greatest common factor may include variables. All right, so you can see 4x squared minus 64. Which statement best explains why 4x squared minus 64 is a difference of squares? So 4x squared and 64 are both perfect squares. 2x, quantity squared, and 8 squared would be what produces those. All right, so it says complete the statement. 2x plus 8 times 2x minus 8 is incorrect factored form of this, because a common factor of 2, see, 2, 8, 2, 8, all of these have a common factor of 2, still remains in the binomial. So this is equivalent to this. This is factored, but it's not completely factored because they still have a common factor. All right, so it says choose the correct expressions to show 2 factorizations of this. All right, so the first one we're going to choose. If we factor out a 2, we're left with 2x squared. And if we factor out a 2 of 64, we're left with 32. All right, in the second, if we factor out a 4, we're left with x squared. And 4 goes into 64 16 times. All right, so that's your greatest common factor, would be the 4. That's the largest number you can pull out evenly. If you pull a 2 out, you can see that 2 and 32 are still even numbers and could still have another 2 pulled out. And then 2 times 2 becomes 4. So when you're pulling out a greatest common factor, always pull out the largest number that's divisible by each term. All right, the next one says, which of the following is completely factored form? All right, so completely factored form is going to come from this right here. So we have 4 times a difference of squares. So we're going to have 4 times x minus 4 and x plus 4. All right, it says explain how you know the answer in part D is completely factored. All right, this is completely factored because there's no more common terms that could be pulled out. There's nothing that comes out of both x and 4, and there's nothing here that comes out of x and negative 4. So we know that this is completely factored form because that's reduced as far as you can reduce it. All right, that's all for task 1. Lesson 17.4, task 2. Factor perfect square trinomials. All right, again, this is another special formula that you need to know. And if you recognize these, it's going to be very helpful. Again, factoring is big on the ACT. This is one of the most commonly missed things on the ACT. So if you learn to understand it now and you continue to use it for the next 3 or 4 years, hopefully you will be successful and get this correct. All right, so previously you have learned how a square of a binomial sum is given by a plus b quantity squared equals a squared plus 2ab plus b squared, and how the square of a binomial difference is given as a plus b quantity, a minus b quantity squared equals a squared minus 2ab plus b squared. For example, x plus 2 times x plus 2, that's the same thing as x plus 2 quantity squared, so it's in this form right here, can be found using the table. So if you have x plus 2 times x plus 2, x times x is x squared, x times 2 is 2x, 2 times x is 2x, and 2 times 2 is plus 4. So you can see how these terms now, like a difference of squares, they canceled, and now you have 2 of them. So the formula says your first term squared plus twice your middle term. So twice whatever AB is, and then plus your last term squared, because 2 times 2 is the same as 2 squared, which equals 4. So if we double this term, 2 times 2x gives us 4x, and that's what our resulting expression is. All right, so this is called a perfect square trinomial, and the reason it's called a trinomial is because this is the trinomial, but it can be factored into a binomial squared. Okay, so a perfect square trinomial can be factored into a binomial squared. All right, so you can factor expressions that are perfect square trinomials by using the factoring patterns shown. All right, again, very important formulas. Here's some examples. I will definitely make sure these are in your notes. All right, so these are very similar. Something squared plus 2ab, which is your middle terms, plus something else squared. So if you know what a squared and b squared is, then you're going to have twice that in the middle. So a plus b quantity squared comes from this perfect square trinomial. All right, same thing, except we've got a negative in the middle. Anything squared is going to be positive. So your first term and your last term will always be positive, because whether you have 2 squared or negative 2 squared, when you square something, it's positive. So the only difference is your middle sign, okay? So if the middle sign is positive, it's going to be a plus b quantity squared. If the middle sign is negative, it's going to be a minus b quantity squared. And you can see examples of these. So x squared is a perfect square. 9 is a perfect square. So you've got x plus 3 and x plus 3, which is x plus 3 quantity squared. And if you look, the 6x comes from x times 3 plus 3x. So 3x and 3x is twice 3x, which is twice 3x is what the twice AB is here. So twice 3x is 6x. All right, same thing here. This expression can be factored as x minus 5 times x minus 5, which is the same thing as x minus 5 quantity squared. All right, so it says factor 5x squared plus 30x plus 45. All right, the first thing I notice is that each of these are a multiple of 5. So it says first recognize that the terms have a greatest common factor. After factoring out the greatest common factor, check to see if the trinomial fits the factoring pattern. All right, so right off the bat, it's not a perfect square trinomial, but the fact that each of these have a greatest common factor of 5, then we need to do that first and then look. All right, so if we factor 5 out of 5x squared, we're left with x squared. 5 times 6x is 30x, and 5 times 9 is 45. Okay, so in this first expression, the only thing we did was pull out the GCF, the greatest common factor of 5. Then this is a perfect square and this is a perfect square, so then we can rewrite it as x plus 3 times x plus 3. 5 times x plus 3 quantity squared. Okay, that would be your final answer here. All right, so it says complete the statement with the correct number or variable. All right, in this case, talking about the one right here, the letter A equals, all right, so it's talking about the formula. Here's the formula, a squared plus 2ab plus b squared. A is what times itself gives you x squared. So in this case, A is x, and B would be whatever times itself gives you 9. So 3 squared, or 3 times 3, gives you 9. So A would be x, and B would be 3. All right, that's all for task 2. If you have any questions, let me know.